Okay, what is the difference between an endocrine and an exocrine? And we're going to be looking at these all the way through this system, so it's very important to understand. An endocrine is a hormone. The endocrine system is the hormone system, the glands. And a lot of organs secrete hormones that you're not used to thinking about, like your duodenum, your stomach has a gland. And so these go into the blood. So if I were to draw, say, the stomach, see if it will let me draw. Oh, please let me draw. Here's your stomach, right? And so these cells here on the stomach, come on, they're going to secrete a hormone called gastrin into the blood. That's an endocrine. At the same time, other cells are going to secrete hydrogen ions and mucus, different cells for different products, into the lumen. Those are exocrines. So an exocrine is technically anything secreted out of the body, which means into the lumen of the digestive system counts as an exocrine. So when you're trying to figure out, is a chemical I'm talking about an endocrine or an exocrine, the question you have to ask is it going into the blood? Is it acting as a hormone? Versus, is it going into the lumen? Is it going out of the body? So that's how you can keep those clear, I hope. And then we think about the first hormones I'm going to talk about. I talked a little bit about gastrin. I'll come back to it. Secretin and cholecystokinin, which is something I will never make you spell. See, if I ask you, like, on a fill in the blank for it, CCK, it is a recognized abbreviation, and nobody spells it out unless they're doing a lecture like this. Gastrin is responsible for the stomach. Secretin and CCK are responsible for the intestinal phase. We'll talk about what they do in a moment. And they're going to regulate the functions of the digestive organs: acid, enzyme, bicarbonate, bile secretion. The other hormones we usually associate with the digestive system are insulin and glucagon, which regulate blood sugar. You've probably heard of insulin before. If you eat something, you want to release insulin so that your cells can absorb the sugar. Glucagon is a hormone released by a different group of cells from the pancreas, and its function is to raise blood sugar if you haven't eaten. I think of glucagon comes in when the glucose is all gone. Glucose all gone, you need glucagon. And then our exocrines, every system secretes mucus, all the way from your saliva glands down all the way through your large intestine. In addition, the stomach has hydrochloric acid, which you've probably heard of. We'll look at how that happens, and pepsinogen. We're going to see this ending inogen on a couple different hormones across the next couple weeks. Inogen means it's a pre-hormone or a pre-enzyme or a pre-hormone. It's a pre-active protein. And what that means is it's stored in the inactive form, because you don't want the active form in your cells. You'll start digesting your own cells, and that would be a miserable thing. So instead, we store it in this inactive form, and it has to be activated later. So we'll see this inogen ending in a couple different places. In the duodenum itself secretes bicarbonate and some small enzymes. And then the liver. The liver is going to secrete bile. Bile is a combination of bile salts and cholesterol and some bicarbonate, some waste products. And basically, bile is not an enzyme because it's a fat. It's basically a watery fat, so it cannot be an enzyme. Versus the pancreas has a large amount of bicarbonate, and then we have enzymes: trypsin, chymotrypsin, amylase, lipase, nuclease. So the pancreas actually makes most of the enzymes for digestion, just like the liver made most of the proteins for the blood. So liver's making the bile here, but it makes proteins for the blood. The pancreas makes the enzymes for the digestive system. Okay, I can do that.